Hello friends, my name is Devendra Dasa and today we see the PPT on construction and working of wind power plants. Wind turbine terminology is cutting speed. This is the minimum speed at which the turbine blades overcome friction and begins to rotate. Turbine are designed to turn when wind reaches a certain speed and a 10 meter per hour is the standard cutting speed. Cutout speed. This is the speed. This is the speed at which the turbine blades are brought to rest to avoid damage from high wind. 25 meter per second, the maximum wind speed in which a turbine can operate before the braking system stops it avoid to damage. Turbine. This is a diagram of wind turbine. Power curve. A graph showing the instantaneous power output for a wind turbine at a different speed. This is the steady power delivered by the turbine as a function of steady wind speed between the cut in and cut out wind speed. This is the actual diagram of power curve. In this power curve, we see that the cut in speed, rated output power, rated output speed, cut out speed, power curve, and etc. Advantages of power curve. Benefits of the power curve. Measurement of the linders. Robust procedure of evaluation of the wind turbine supplier and the turbine model reduce the uncertainty of the energy calculation by the minimizing a sufficient contribution of uncertainty. What the actual power performance is the site conditions. Fourth is rated wind speed. Wind turbines comes with the nameplates listing their optimum level of energy production. The rated wind speed is the corresponding wind speed that allows the turbine to achieve the nameplate rating. This is usually 30 to 35 meter per hour. Fifth is survival wind speed. It is the maximum speed of the wind above which wind turbines will be damaged and speed up to up to uh, which wind turbines will be damaged and speed up to which the turbines are designed to withstand safely. For commercial wind turbines, the survival speed is in the range of 14 meter per second to the 72 meters per second. Sixth is nominal wind speed and nominal power output. Nominal wind speed and nominal power output. This is the lowest speed at which the turbine reaches its nominal power output. Above the speed, higher power outputs are possible, but the rotor is controlled. Threshold wind speed. The cut in and cut out speeds are the operating limits of the turbine. By operating in the range of ensure that the available energy is above the minimum threshold and structural health is maintained. The turbine designed above the rated wind speed is not cost effective. Major parts and function of wind power plants. First parts of wind power plants is blades. The blades act as a barrier to the wind. When the wind forces the blades to move, some of the wind energy is transferred to the rotor. Blades for mechanical system of wind turbine which converts wind energy into the unstable mechanical energy. Wind energy rotates the blades of turbine. This rotation transfer its mechanical energy to the shaft. Blades are generally manufactured with the fiberglass and carbon fiber layers on synthetic reinforce. Normally, three identical blades are fitted to a central hub using nut bolts. Blades are arranged at the 120-degree to each other. This is total parts of wind power wind turbine. Hub of wind turbine. Hub is the component that consists the blades to the main shaft and or ultimately to the rest of the drivetrain. Blades and hub together forms a rotor. Hubs are generally made of steel, either welded or casted. Gearbox is inserted between the rotor hub and generator. Function of hub. In a wind turbine, the rotor hub transfers the mechanical energy from the wind into the drive train and with several loading components. Only the torque components is useful for the generator to produce electricity. The other loading components are transferred towards the tower. Nacelle. It is the big box mounted on a tower and house all the components of the wind turbine. It is house electrical generator, power converter, gearbox, turbine controller, and cables and your drive. Gearbox, it is increase the shaft speed and matches the generator speed. Wind turbine rotates at a low speed and generator rotates at a high speed. Speed to generate electricity at desired voltage level, so that must be some multiplication arrangement to the achieve high speed of the generator, and gearbox the does this and increase the speed of higher value. The diagram of generator is an electrical device that converts mechanical energy received from the wind turbine shaft into the electrical energy. Permanent magnet synchronous generator, that is PMSG, or induction generator are used in some wind power plants. Direct current generator with the inverter system is used. Pyroelectronics controlled electronic converters. As wind energy is variable, so electrical energy from a generator is not a constant, and it becomes necessary to power flow keep the constant output voltage to the transfer it to grid. Converts also enable transfer to active and reactive. Turbine controller, it is the computer program, that is PLC, that control entire turbine and offers a self diagnostic in case of any error in the turbine. Relation principle, rotation principles, drag and lift principle. This is a prince. This is a diagram of angle of attack and lift and drag principle, that is rotation principle. Turbine. A turbine is a device that harnesses the kinetic energy of some fluid, such as water, steam, air, combustion gases, and turns. This is the rotational motion of the device itself. These devices are generally used in electrical generation, energy and propose energy systems, and are classified as a type of engine. Different types of sensor. Anemometer. It is a small device that it is a small device with three blades, and it is used to measure speed of wind. With the values, electronics controller decide to the lead the blades of wind turbine or stop them in case of high wind. It consists of three cups of horizontal arms with a 120-degree separation. Wind speed formula is V is equal to 2 pi, where V is equal to wind speed in a meter per second, R is equal to radius of circle formed by cups, T is equal to time of all laps in second. Wind vane. A wind vane is used to determine the direction of wind, and with that the electronic controller can be determined more appropriate direction of the blades to have maximum possible energy anemometer. Vibration sensor, it is the very simple safety sensor. As the turbine starts shaking, whole mechanism turns of the wind turbine. Vibration sensor, it is a very simple safety sensor. As the turbine start shaking, whole mechanism turns of the wind turbine. Eddy current sensor, it is the measure it is it measures the lubricating gap of the shaft to ensure it is always converted by a thin film of oil that is applied under pressure. It is also measure the torque deflection of cloth, disc, and etc. Displacement center sensor. It is used to monitor structural integrity. Capacitor sensor is used to measure the generator air gap. Accelerometer. It is used to turbine to detect and monitor vibration within main yaw and slope bearings and shaft. It monitors changes in the wind speed. Wind sensor. Wind sensor are mounted on the top of nacelle and either mechanical or ultrasonic. It measures the distance of the object. Temperature sensors. It is used in location where a temperature increase and indication given for overheating of components. Different types of actuators. This are used in a wind turbine as a motor or a energy sources to move and control certain components. There are two types of actuators used in wind power plants: hydraulic and electrical. Hydraulic actuators are important for the control mechanism of the turbine system. Paris actuators drives offers highly efficient turbines operation, lower production cost, and minimize maintenance cost. Following two axis control are available in wind power plant. पूर्ण बोल तिचा. Yaw and pitch control. Pitch control. Yaw control keeps the turbine facing the wind. Pitch control continuously adjusts the angle of blades and to ensure as high and constant power output as possible and protect blades from being damaged by overspeed. When wind speed is high, blades will go into aerodynamically stall, braking and loss lift. Pitch control can be done by two ways, electrically or hydraulically. Electrical pitch control: in this system a motor with an attached brake is coupled to the pitch control mechanism throughout the gearbox. In case of a power failure, batteries will ensure the movement of blade. Hydraulic pitch control. Hydraulic pitch control system provides a robust and reliable control of power and speed of modern wind turbines. During emergency stops where the pitch of the blades has to be taken to a full stop position to avoid overspeed situation. Hydraulically accumulators play a circular role in this system. Blade angle is controlled by one or more hydraulic cylinders placed in the hub of the turbine. Cable untwisting. Wind power generation cable connect the primary generator motors in the turbine nacelle with the transformer and supply the electricity produced in the power grid. Highly flexible cables are required so that they will sustain without damage even the generator rotates thousands of cycles. As a cable carry the current from the wind turbine generator down through the tower. The cables, however, will becomes more and more twisted if the turbines by accident keeps going in the same direction for long time. The wind turbine is therefore equipped with a cable twisted counter which tells the controller that it is. Braking mechanism in a wind turbine. Braking system is one of the most important safety device. The braking system of a wind turbine ensure that it automatically stops when it is detects the one of its critical critical components does not work properly. A wind turbine system compresses a variety of sensor to detect any incidents from overheating of generator to protection against high wind turbine. Two types of brakes are used in aerodynamic braking and mechanical braking. Aerodynamic braking, active pitch control. Blade pitching provides a highly effective means of aerodynamic braking. In a large wind turbine, pitch mechanism enable the rotation longitude axis and it can changes the angle of attack of blades with respect to the wind, by which the aerodynamic characteristics of the blades can be adjusted protect the turbines and also improves improves conversion efficiency. Mechanical brakes. Mechanical brakes consist of a steel brake disc acted on one by one of a move brake calipers. It can be brake calipers. It can be situated on the rotor shaft for low speed shaft or on between the gearbox and generator. For high speed shaft, hydraulical and electromechanical disc brakes are often minimize wear the term and brake and reduce the stress or on drive train during the braking process. Most large wind turbines use the aerodynamic power control to reduce to a certain level or zero and then the mechanical brake to stop or lock the wind turbine. As per IEC 614001, mechanical brake should be able to bring the turbine rotor to complete stop at any wind speed. Thank you.